equals the area swept in May and June. Kepler's third law, the law of periods. Kepler.
What is the third law? Also called as law of periods. Okay, ma? So please write it. Kepler's third law is also known as law of periods. Okay, so right.
Kepler's third law is concerned with the time period of revolution of planets. It states that the square of the time period of revolution of a planet in its orbit is directly proportional to the cube of the semi-major axis of the elliptical path around the Sun.
You won't understand, I'll say
For a
you.
circular path, t square is proportional to the cube of the radius of the circular path. For example, for Mercury, the length of the semi-major axis is 0.39 astronomical units, and its time period around the Sun is 0.24 Earth years. For Mars, the length of semi-major axis is 1.524 astronomical units, and the time period of revolution around the Sun is 1.88.
See, what is Kepler's third law means? Now we all know around the Sun how many planets are revolving. Anybody can tell? We'll consider it 8 planets are revolving. Am I right or wrong? Please respond, guys. All of you?
Yes, sir.
Yeah.
Yes,
So
sir.
different planets are revolving in different orbits. Now here they have taken 2 planets. What is the 2 planets? One is Mercury. Another one is what? Mars. So let me take 2 planets. 2 planets around the Sun. Now do you think that both are in the same orbit or different orbits? Everybody?
Different orbits.
Different orbits. So means if I consider different orbits, definitely the semi-major axis is different. Of course, we'll take it as an average radius because this Kepler's third law will be derived. So definitely they'll be having a semi-major axis is different. For Mercury, this will be the semi-major axis, and for Mars, this will be the semi-major axis. So for example, if I take Earth will be some other thing is the semi-major axis. Am I right or wrong? Everybody clear? Please respond. So now, is it all the planets are taking the same time for revolving around the Sun or different time period for different planets? That is what is my question. Anybody?
Different time period.
Different time period. Do you understand, everybody? So, what is Kepler's third law will says that if you take it here, that square of the period of revolution of a planet around the Sun, if you take any planet, square of the period of the revolution of the planet around the Sun is directly proportional to the cube of the average radius of the planet orbit. So I'm taking average radius because is it radius is equal or varies in orbit? Is it radius is equal or orbit every time? If I take it as a circular path, radius is always what? Anybody? Equal. If it is a circular path, radius is always equal, but it is an elliptical shape. Is the R remains constant or varies?
Varies.
Varies. That is why I am taking not R. I am taking a average radius. Do you understand, Mr. Mari? Agalya? So average radius of the planet. So if I take, so square of the time period of a planet is directly proportional to cube root of average radius of the planet orbit. That is only called as Kepler's third law. Now, I take for the Mercury. Mercury time period is, let me consider T1 and average radius is R1. And Mars. Mars time period is T2 and average radius is R2 cube. If I take Earth, let me take time period of Earth is, let me take T square and average radius of Earth is RE cube. So if I find it everything, mathematics, we want to remove the proportionality. What will get, guys? Anybody can tell me? So T1 square is equals to, please all of you say that, constant into R1 cube. T2 square is equals to constant into R2 cube. Like same way, Earth, T square is equals to constant into RE cube. Is it okay, wa? Girls and boys, all of you understand, Amma? Please respond. Now I want
according to planetary motion, time period in the sense the
listen, square of time period. Yes, Mari. So now if I make yes, Mari, ask me.
time period in the sense the time taken to complete one
One
rotation.
revolution. Time taken
Zero.
to complete one revolution. Do you understand, Amma? All of you? Girls, that is what. So T1 square divided by R1 cube is equals to constant. Same way, T2 square divided by R2 cube is equals to constant. And T square divided by RE cube is equals to constant. So that is only called as Kepler's third law. If you do the ratio of square of time period divided by cube root of radius, average radius, not radius, it is a what, everybody? Average radius of the planet's orbit, which is always remains constant for every planet. That is only called as Kepler's third law. It has been proved also. Even we will calculate it. Numericals will solve it. So time period of third body divided by cube root of this one, or if you take Earth, time period of Earth, square of time period of Earth divided by average radius of Earth is always remains what? Equals to constant. So that is only called as Kepler's third law. You will get the same value always. That is what it is called as law of periods. What is to call, guys? Everybody? We is to called as law of periods. Different planets is having different time period and different radius, average radius. But still, if you do the square of time period and cube root of radius, average radius, the value will be getting remains constant. That is only called as Kepler's third law. We'll solve the numerical also. Even we'll prove that numerical also. We are getting the same. We can do it all.
Earth years. Observe
Here they have given, you can see, guys. Mercury. What is the semi-major axis? What is the semi-major axis? 0.39 angstrom units, and time period is 0.24 Earth years. Same way, Mars, semi-major axis is 1.524 angstrom units, time period is 1.88 Earth years. Now, if you do the ratio, you can see you'll get the same.
that the ratio of the square of the time period to the cube of the semi-major axis is
See, cube root of semi-major axis. Why they are taking means average radius it is, because it is not elliptical, it is not a circular shape. If it is a circular shape, we will take it as a what? R is remains constant or not? Mr. Mari, Lingesh, understand? If it is a circular shape, it is R is remains constant, but it is not a circular shape. It is the elliptical shape. That is why we will take average radius of the planet's orbit. Please remember that.
almost the same for both the planets.
You can see that. Remains
I
what?
have one doubt, sir.
Yes, ask me.
So by dividing square of time period and cubic root of radius, what we will get, sir?
We'll get some value.
That value is known as?
That value is remains constant for every planet. Every planet, that values remains constant. That is only called as Kepler's third law. Do you understand?
Yes, sir.
Are you clear?
Yes, sir.
Even they have given
Sir,
you the
then
proof
can
also.
we say?
Yes.
Then can we say t square proportional to cubic r is?
Yes. That is only Kepler's third law. Understand?
Yes, sir. Is equal to all the planets.
For every planet, it is same. That's what it is. Okay. Once again, you can come from here.
For
Everybody.
example, for Mercury, the length of the semi-major axis is 0.39 astronomical units.
Write it. Astronomical units. That is the semi-major axis length. Astronomical units. Write it, guys. And what is the time period? 0.24 Earth years.
And its time
Mercury.
period around the Sun is 0.24 Earth years. For Mars, the length of semi-major axis is 1.524 astronomical units, and the time period of revolution around the Sun is 1.88 Earth years. Observe that the ratio of the square of the time period to the cube of the semi-major axis is almost the same for both the planets.
Now, if you want, you can write it. One astronomical unit here. One astronomical unit is equals to 149597871 kilometers. Clear? All of you?
Sir, can you repeat it?
One AU. 1 AU is equals to 149597871. That is what? Now 0.39 AU means 0.39 into this value you have to multiply it. So you will get it, what is the value? Now semi-major as here 1.524 AU means 1.524 into this value you have to multiply it. That is what one astronomical unit. Are you clear, Lingesh?
Yes, sir.
Yes. Next, 0.24 Earth years. What is the Earth year? How many years? Earth 1 year. Am I right or wrong? Please respond.
According to the countation of a
Yes. Earth year. Earth year, if you have taken, what is Earth year? 365 days. Okay. So now 0.24 Earth years means how much it will come? 0.24 into 365 days. If you multiply it, you will get the time period. Here also same. 1.88 Earth years means 1.88 into 365 days. If you multiply, you will get the number of days. Are you clear, Lingesh, Kishore? So that is what you have to remember. So different
Yes, sir.
planets is having different time period. Different planets is having different semi-major axis. Of course, here they're taking semi-major axis. You can take average radius of the planet's orbit. If you do the square of time period of planet is directly proportional to average cube root of average radius of the any planet. That's always remains constant. That is only called as Kepler's third law. I hope you all understand. So this will help us. Kepler's third law will help us to calculate the time period of a planet and as well as average radius of the planet. We'll find the formula also in the coming classes. It is not there for school, but our syllabus, it will be there.
So it helps us to find what, sir?
It helps us to find the time period of a planet, the orbital radius of the planet, everything we can calculate in our daily life. Okay. So those who are studying in a space technology and all, they will use this Kepler's third laws only to study the planet's motion, everything, the time period calculation, average radius calculation and all. Please note it.
Summary. Kepler's first law states that all planets move around the Sun in elliptical orbits, with the Sun at one of the
Sun at the one of the focus, not at the center of the orbit. Are you clear, everybody? So that is why first law is called as what? Law of
Orbits.
orbits. Second law.
foci, not at the center of orbit. Kepler's second law states that the line joining the Sun and planet sweeps out equal areas in equal.
Write it properly, this definition. Equal sweeps out equal areas in equal interval of time. I'll send you this video also, don't worry. But
Can you please read, sir?
yeah, you understand or not is very important. So what is the second law, everybody? Second law called as law of
Areas.
areas. We used to say. Yes, that is what. Mr. Nivedan understand, Sam? Pranav? Parasini? Alfin? I'll check the notes tomorrow.
Intervals of
Yes.
time. Kepler's third law states that the time period of revolution of a planet in its orbit is directly proportional to the cube of the semi-major axis of the elliptical path around the Sun.
That is only Kepler's third law. Okay, right. Kepler's third law states that the square of, here missing square word, the square of, write that word, the square of the time period of revolution of a planet in its orbit, square of the time period of a revolution of a planet in its orbit is directly proportional to the cube of semi-major axis of the elliptical path around the Sun. If you don't want semi-major axis, you can take average radius. Please write it. Average radius of the planet's orbit. Average radius of the planet's orbit. That is what R. So this is what you have to remember. Are you clear, everybody? Please respond, guys. All of you? Yes, anything doubt, please let me know. So this is what is about Kepler's third law. So anybody having any doubt, you can ask me or else you can finish it. So this is only Kepler's third law of motion. So from this only Mr. Newton derived Newton's law of gravitation. So the most important law which is universally accepted. So we are going to study that Newton's law of gravitation in our tomorrow's class, and we are going to derive the Kepler's and Newton's, what is the relationship between Newton's law of gravitation and Kepler's laws. How Mr. Newton has guessed the used the Kepler's laws to derive the universal law of gravitation. We'll study in our tomorrow's class. So with this, I'll stop. I hope you all understand, and it looks very. I'll send this video also. You can learn whenever you want. You can watch. With this, I'll stop. Thank you. We'll meet in tomorrow's class.